In this video, I'll share with you how to build a custom aim trainer in Python that you can make as easy or challenging as you want. Now, this is a great project for anyone who's a beginner or intermediate Python programmer just looking to work on something fun that will help you practice your skills. I don't assume any advanced Python knowledge in this video, but I am assuming that you've worked with Python before, you've maybe done a project or two in the past, and you have some idea about basic syntax like for loops, functions, classes, etc. Regardless, this is a great project. I won't delay the intro anymore. Let's go ahead and get into it, and I'll show you how we can build this aim trainer. So we'll dive into building that project in 1 second, but I just want to share with you that I do have a course known as Programming Expert, which is for anyone looking to get better at programming and become a software engineer. This course covers all kinds of different content, but specifically focuses on Python, Go, and all of the necessary skills like software engineering tools that you need to land a job. You can check that out from the link in the description. And if you're interested in blockchain or Web3 development, I have another course called Blockchain Expert. I'll leave that link down below as well. Okay, so now that I've gone through that, let's go into a new file here and let's start working on this aim trainer. But actually, I'll just quickly demo it so we can talk about kind of what we need to do here. So you can see that what I'm doing is tracking some different stats. So I've set a number of lives. That's essentially how many targets you have to miss before the aim trainer is going to finish and tell you what your stats are. I've set it really high for the demo, but typically we'd have this at something like 3 or 5. We then have stats that are keeping track of the number of hits you have, the number of targets you press per second, and the total time elapsed. Obviously, we have targets that are appearing randomly on the screen. You can press on them, and you'll see that they are shrinking and kind of growing as they appear. So they grow up to a certain size, pause for a second, and then shrink back down. That's exactly what we're attempting to do. Okay, so now that we've looked at that quick demo, we have some kind of idea of what we need to build here. Let's go into a new Python file, which I'm in right now, and let's start working on this project. Now for this project, I'm going to use a module called Pygame. Now Pygame is something we need to install. So what we're going to do here is go to our command line or terminal and type pip install and then Pygame. Now I already have this installed, so I'm not going to run that command. For you, you may need to do pip3 install Pygame if you're on Mac or Linux. You can also try python-m pip install Pygame or python3-m pip install Pygame. If none of those work, I will leave 2 videos on the screen that show you how to install Pygame. Okay, so now that we have Pygame installed, we can start working it. So we're just going to do a few imports here, define our Pygame window. Don't worry if you've never used Pygame before. It's super straightforward, and it's actually a really great thing to build some basic user interfaces in Python. So I'll walk you through all the steps. Let's start by importing Pygame. We are then going to type pygame.init, which is going to initialize Pygame and initialize the fonts and some other things that we need. I'm then going to go up here, and before Pygame, I'm going to import math because we're going to use that. I'm going to import random. We're going to need that as well. And then I'm going to import time. Okay, I think that's all we need. Now that we've done that, we're going to define the width and the height of our window. We're going to create a window object, and then we're going to create what's known as the main loop for our Pygame project. So we're going to say width, comma height is equal to, and then I'm going to go with 800 and 600. Now keep in mind, if you're on a smaller display, you may need to make this a little bit smaller. I'm on quite a large display, so you'll see that this is kind of a good size. But for some of you, you may want to do 600 by 400. This is the number of pixels you're going to be using for the window, okay? So now that we have the width and the height, I'm going to define a window object. So I'm going to say win is equal to pygame.display.set_mode. And inside a set of parentheses, I'm going to pass my width and my height. Now what this will do is initialize a Pygame window and display that on the screen. So this is going to pop up kind of a black window that will have an 800 width and a 600 height because we passed that inside of the parentheses. Once we have this window, we can then draw things onto it, which we'll do in a minute. So next, we're going to say pygame.display.set_caption. And the caption for this is simply going to be aim trainer. Now the caption is just the name of the window. You don't need to set this, but I like to do this for my projects. Okay, so now that we've done that, let's create what's known as the main loop of our program, which is essentially an infinite loop that will check for different events. So pressing on the screen, quitting the window, if a target appeared or disappeared, that's what we're going to be doing inside of the main loop. So we're going to say define main, which is our main function. Now inside of here, we're essentially going to create a while loop that will run forever until we quit the window. So we're going to say while run, and we'll define a variable here called run. We'll make that equal to true. And inside of the while loop, what we're going to do is loop through all of the different Pygame events and see if the user quit the window. Now, you'd think that it's already built in that when you press the X button, it's going to close the window. That's actually not the case here in Pygame. What happens when you press the X button is an event will be triggered, and we then need to respond to that event and close the window for the user. So to do that, we're going to say for event in pygame.event.get. Now, what this is going to do is loop through all of the different events that are occurring. So that will be kind of equal to the event here. And then we will check if this event is equal to the quit event. If it is, then we'll quit. So we'll say if event.type is equal to pygame.quit like that, then we're simply going to say run is equal to false, and we're going to break out of this for loop here. Okay, so now what we have is a while loop that's going to run while this variable is true. We then loop through all of the different events that are occurring as we go through this while loop. So at pretty much every millisecond or however fast this while loop is running, we're looking at all of the events. If one of the events is quit, then we're going to break the loop and get outside of it. So now if we're outside of the loop, we're going to say pygame.quit, and that's going to quit the Pygame window and close it. And then we're going to come down here and we're going to say if __name is equal to __ main, then run the main function. Now what this will do is just ensure that we're only running the main function if we're executing this file directly. Don't worry too much about this if you haven't seen it before, just a nice line to add in to make sure if we import one of these functions from another file, it doesn't cause this game to run. So now let's quickly test this out. You can see when I run this, a window appears that says aim trainer, which is 800 by 600. And then if I click on X, it closes the window and all is good. Perfect. That's all we needed for right now. Okay, so now that we have our main loop implemented, what we need to do is start putting some targets on the screen, viewing those targets, and then seeing them kind of shrink and grow. So what we're going to do is create a class, which is going to represent our targets. So we're going to say class target like that. And inside of the class, we're going to define a few variables that we need for the target. Remember, it's kind of growing and shrinking. So we're going to set a maximum size for the target, which is essentially the size at which we want to start shrinking. So we'll grow up to the maximum size. As soon as we hit that, we'll start shrinking. So the max size will be 30. You can change all of these values, by the way. I'm then going to say the growth rate is equal to 0.2. Now, this is how many pixels we want to grow the target per frame. Now, we'll talk about frames in 1 second, but both of these values you can adjust, and as you adjust it, it will make the aim trainer more difficult or easier, depending on the direction you go in. Then I'm going to set the color for my target equal to red. You'll see why we want that in a second, just so that we can kind of change the color target quite easily. Okay, next we are going to define an initialization. This is what's known as the constructor for our target. Inside of here, I'm going to take in self, x, and y. Self will refer to the target itself that we are calling this constructor on, and x and y will be the position where we want to place this target on the screen. So we'll kind of randomly generate those positions, and then we'll store them inside of the target object. So we'll say self.x is equal to x, and self.y is equal to y. We're then going to define two variables here. One is self.size is equal to 0. Now the size will be the radius of the target. It's going to start at 0, and then we're going to increase it by this growth factor until it hits the maximum size. Once it hits the maximum size, we'll start shrinking it down, so then it gets to 0, and then once it's at 0, we'll make the target disappear from the screen. We're also going to have an attribute here called grow. We're going to start this equal to true, but then we need to make this false as soon as we hit the maximum size, so we start shrinking rather than growing. Great. So now let's write a method that we can call to update the target size, which we'll need to do. So we're going to say define update, and we're going to take in self. Now what we'll do in here is we'll essentially check if we should be growing or shrinking, and then adjust the target based on that. So we know that we need to start shrinking the target as soon as the current size of the target is going to be greater than the maximum size. So I say if the self.size plus the self.growth rate is going to be greater than or equal to the self.maximum size, then I need to say self.grow is equal to false. So as soon as I add this growth rate and it causes the size of my target to be greater than or equal to the maximum size, I need to set grow equal to false. Okay, then I'm going to come down here and I'm going to say if self.grow. So if we are growing, then self.size plus equals the self.growth rate. Otherwise, if we're not growing, we must be shrinking. So we'll say self.size minus equals the self.growth rate. Okay, so now we have a function that will handle sizing our target and making it larger or smaller based on if we're growing or not. Okay, now we need a function that actually draws the target onto the screen. So we're going to say define draw. We're going to take in self, and we're going to take in a window object that we want to draw this target onto. Now, the way we draw something in Pygame is different depending on the thing that we're drawing, but in our case, we want to draw a circle. So we're going to say Pygame dot draw dot circle. Okay, now what we pass here when we're drawing a circle is the window we want to draw the circle onto, the color of the circle, and then the center position of the circle as well as the radius, okay? Having all of those different pieces of information allows Pygame to put this on the surface. So in Pygame, we're constantly dealing with surfaces. This window here is going to be our window object that we've created, and we're saying, yes, we want to draw this circle onto the window. Where do we want to draw it? What color is it? How big should it be? That's what it's asking us. So we're going to put win because that's where we want to draw it. We're going to put self.color because that's the color we want the target to be. And then we're going to pass a tuple that contains the x, y position of the center of the target. So we're going to say self.x, self.y, that's the center of the target. Then we're going to pass the radius or the size of our target. So we're going to say self.size. And when we pass self.size, whatever the current size is, well, that's the size we'll be drawing for the radius of the target. Meaning as the size increases, we'll be drawing larger and larger circles. Now, for now, this is just going to draw a red circle. However, if we want to draw kind of that target style circle where we have, red, white, etc., we actually need to draw 4 circles. The first one will be the largest circle. Then we'll draw smaller and smaller circles that will overlap each other, and cause this kind of ring pattern to appear. So what I'm going to do is draw 4 circles here. So I'll just kind of copy this down 4 times. And what we'll do is we'll adjust the size. So we'll say self.size times 0.8. Now it's important that we do this by some kind of multiplication factor so that as the size of our target changes, so does the size of all of the rings inside of the target. I can't just say, draw this size 20, draw the next one size 30. I need to do it dynamically based on what the current size of our target is because it's going to grow and it's going to shrink, right? Okay, so we do times 0.8. Then we're going to do times 0.6, and then times 0.4. And if you want the rings to be spaced out differently, then you can adjust these values, but I think this will give us a nice ring shape for our target. Now what we need to do is just adjust the size, the color of our targets. So we have self.color here, and in fact, let's go and say we have a second color, which is equal to white. Okay, so we'll use the color variable for the red rings, and the second color variable for the white rings. So now I'm going to go here and change each kind of second target drawing here to be the second color. So we have color, second color, color, second color. You can see that we're constantly going smaller in size. So what happens is we draw this very large circle. Then on top of that circle, we draw one that is a little bit smaller. Then on top of that, a little bit smaller, on top of that, a little bit smaller. And what that does is overlap these different circles, causing us to have this kind of ring shape. In Pygame, the order in which you draw things is important. When you draw something after something else, it's going to go on top of that object or overlap it. So that's why we're able to accomplish this here with these 4 draws. Okay, that's fantastic. So now we have our target. We've created that. And what we need to do is start making these targets appear on the screen. So how are we going to do that? Well, we need to go into main here, and we need to create a variable called targets. Now, this is where we're going to store all of the different targets. Then what we'll do is we'll loop through all of the targets we have, we'll update their size, and we'll draw them on the screen. But every X seconds, we need to kind of place a new target onto the screen. So to do this, we're going to create what's known as a custom event. Now, this event will essentially be triggered every 500 milliseconds or 600 milliseconds or whatever we want. We can then check for that event. When that event occurs, we can then make a new target at a random position and add it inside of this array. So let me show you how that works. We're going to go to the top of our program, and we're going to define 2 variables here. The first variable we're going to define is the target underscore increment. Now, this is going to be equal to 400 milliseconds. Now, you can change this if you make it if you make it less, so like 300, 200, it's going to be much harder. If you make it larger, it's going to be much easier because the targets appear later. So I've gone with 400 milliseconds, but you can adjust that as you want. Next, I'm going to say target underscore event is equal to pygame.userEvent. And then I'm just going to define another variable here, which is the target underscore padding, which is essentially how many pixels I want this to be off the edge of the screen. We'll just put this here for now, and then we'll kind of look at that in a second, but I'll set that to be 30. Okay, So we have a custom event, which is the target event, which is a pygame.user event. We then have the increment, which is the number of milliseconds that we want to delay until we create another target. Now that we've defined those variables, we're going to start using them down here. Sorry, I didn't mean to kind of scroll through that crazy. So what I'm going to do is essentially create a timer. So I'm going to say pygame.time.set_timer. And the timer that I want to trigger is the target event. Then I'm going to put the target increment. Now what this says is trigger this event every target increment milliseconds. So we're going to trigger the target event every 400 milliseconds. That's what we're doing. Okay, so now that we have that timer, what we'll do is we'll go inside of our event loop here and we'll listen for that event. And when that event occurs, we'll make the target appear on the screen. So I'm going to say if event.type is equal to, and now we're going to use our custom event, which is the target event. So as soon as I see this occurring, I want to create a new target. To create a new target, I need to randomly generate an X and Y position for it, then create the target and add that to my target array or my target list. So I'm going to say X is equal to random.random integer, and we're going to generate a random integer for X in the range of our target padding and our width minus our target padding. Now, the reason I'm doing this is to ensure that my targets don't appear off the screen. Since we're drawing from the center position of our target, that means the radius of our target will go to the right and it will go to the left. So if I had a position like 10, 10, so I'm drawing at X position 10, X position Y, but my target has a radius of 30, that means my target will really appear from kind of negative 20 here all the way to 30, right? Or sorry, not 30, all the way to 40, because the radius is 30, so it's going to take up 30 pixels on each side of the X and Y coordinate. Hopefully that makes sense, but if this is the center position, then the radius kind of expands outwards. So I need to make sure my center position is such that when the radius is applied to my target, it doesn't appear off the screen. So that's why I have this target padding here. I'm generating a random integer between the target padding and between the width minus the target padding to ensure the center position causes the target to not be off the screen. Now I'm going to do a similar thing for my Y. I'm going to say Y is equal to the random.randint, and this will be, again, the target padding, and then the height minus the target padding. Okay, I'm then going to say target is equal to target, and I'm going to pass my X and Y. So I'm initializing a new instance of the target class. Then I'm going to say targets.append target. And what this will do is now push this new target object into this list so then we can use it and loop through it. Great. So now every X seconds, every 400 milliseconds, whatever we define in the variable, we will create a new target. What we need to do next is update all of our targets and draw them on the screen. Now, what I like to do is put all of my drawing inside of a separate function. So I'm going to write a new function here called draw. I'm going to take in a window object, and I'm going to take in my targets. Now, in Pygame, remember I told you that the order in which we draw things is important. If we draw something over top of something else, what that's going to do is overlap it. So essentially what we need to do inside of this draw function is we need to clear the screen every single time we draw. So we're going to wipe the entire screen clear by drawing something over top of it. Then we're going to draw all of our objects. Then we're going to update the display. And we're going to do this every single frame. So every frame, we wipe what was on the screen previously. Then we draw onto it what we want to see next. So it's kind of frame by frame rendering. That's what we're doing here. That's not how it works in every single system. Anyways, what we do is we type win.blit, .fill, and then we can fill the window with a specific color. Now you can just write in a string the color you want. So if you want it to be yellow, you can write yellow. If you want it blue, write blue. But if you want a more specific color coding like what we have, then you can use an RGB value. So what I'm going to do is go to the top of my program, and I'm going to say my BG_color is equal to, and then I'm going to specify the red, green, blue value that I want to draw. So in this case, it's going to be 0, 25, and 40. Now, if you're not familiar with how RGB works, this is essentially 3 values in the range of 0 to 255. Now, all 3 of these values tell you the number of red, green, and blue. So the first value, 0, means I want to have no red. 25 means I want 25 green, and then 40 means I want 40 blue. And the maximum is 255. So as you kind of change these values, you get different colors. That's kind of how RGB works. In Python, you define 3 values in a tuple, and then you can use them inside of a function like this. So I can pass my background color, and now I'm going to fill the entire window with the background color. Next, I'm going to loop through all of my targets. So I'm going to say for target in targets. Then what I'm going to do is say target dot draw. And I'm going to pass this window object. So if we go and we look at the draw function here, you can see that it accepts the window. So we just pass the window here, loop through all of the targets, draw them all on the screen. Lastly, we type pygame.display.update. Now the display is only going to draw all of the things that we've kind of rendered up until this point when the update function is called. So once we've drawn all of the targets and we filled the screen in, then we will call update and we'll draw them onto the screen. Perfect. That's the draw function. So now we need to make sure we call the draw function. So I'm going to go inside of my while loop and I'm going to call draw, and then I need to pass my window and my targets. So I'm going to pass win and targets like that. Now we're almost done, at least with this step. What we need to do next is we need to make sure that we update all of our targets before we draw them. So I'm going to say for target in targets, and I'll simply call target.update. Okay, so now what this will do is update all of the targets. By updating them, we're going to change their size, right? We're going to make them grow or shrink depending on where they currently are in the animation. Now, there's a few more things we need to do, but for now, let's run this and see what happens. Okay, so actually, just need to fix something there. Let's run, and you see that the targets kind of appear very quickly on the screen. Now, the reason they're going so quickly here is we haven't set what's known as the frame rate for our window. So let's fix that, then you should see that things get a little bit better. Okay, so how do we fix the frame rate? Well, inside of this while loop here, essentially what's going to happen right now is all of this stuff is just going to run as quickly as our computer can execute this while loop, because it's kind of an infinite loop, right? But what we can do is regulate the speed at which this runs by introducing a frame rate. So to introduce a frame rate, we're going to create a clock object. We're going to say clock is equal to pygame.time.clock. We're then going to go inside of here, and we're going to say clock.tick, and we'll just put a 60 inside of here. Now, 60 means I want you to run this while loop at 60 frames per second, meaning that no matter what computer we're on, as long as it can run minimum 60 frames per second, then we're going to run at 60 frames here. So this tick just regulates the speed at which this while loop runs, which means this code should run at the same speed on your computer as it does on mine. If we didn't have this, we're running based on the processor speed, which can vary drastically, even just based on what you're doing on the computer. Okay, so let's go ahead and run this now, and we should see that now our targets are kind of appearing a little bit better, right? So they're growing, they're shrinking. Yes, some of them are overlapping. That's fine. We haven't introduced logic for that, and they're appearing on the screen. Now, what you'll notice is if we let this code run for a while, it will start to get slower and slower. Now, the reason it's going to get slower and slower is because we're not disposing of our targets once we put them, once we shrink them down to a 0 size. Right now, what happens is this targets list just keeps getting larger and larger and larger and larger every time this event happens. What we actually need to do now is we need to make sure we remove these targets as soon as they have a 0 size. So we start growing them, and then as soon as they shrink all the way down to 0, we'll want to get rid of them so our computer doesn't have to handle them anymore. So how do we do that? Well, the way we do that is the following. We're going to say if the target.size is less than or equal to 0, then we want to remove this target from the targets list. So we're going to say targets.remove and then target. Now that's just going to get rid of it and take it out of this list, meaning the next time we run this code, we're not going to be iterating over it, which means we won't kind of be doing all of these unnecessary operations on a target that's currently invisible. Hopefully that makes a bit of sense why we're doing that, but we just need to remove it as soon as it has a 0 size. Now, the reason we put this if statement here and not before the update is because we want to update it first, which means if it currently had a size of 0, because it starts out on 0 size and it's growing, then what will happen is it will get a size of 0.2 or 0.4, whatever the size ends up being, meaning we don't remove it if we just added it inside of this array. If I had put this if statement before, then we would never see a target appearing on the screen because as soon as it was added, it would have a 0 size and then we would remove it. So since we're updating first, that means if we just added the target, it will be growing, so it will have a larger size than 0. So we won't remove it, until its size shrinks back down to 0 after it has already been displayed. Okay, so let's run this now, and you'll see that the code works the exact same. Now what happens, though, is as soon as the target reaches 0, we remove it, and we don't get any errors. Okay, There we go. So now our targets are appearing on the screen. The next thing we should probably do is make it so that we can press on the targets. So what we need to do is essentially get our mouse position whenever we click down, see if that's colliding with the target, and if it is, then we need to remove that target and then increment some kind of variable indicating that we pressed on the target. So how do we do that? Well, the first thing that we're going to do here is just define some variables related to kind of our analytics as we play this game. So we're going to have a variable called target pressed, which is equal to 0. We're then going to have the number of clicks that we've made in total, which will be 0. We then want to track our time. So we're going to say the start time is equal to time.time. You can find the time imported all the way up here. Okay. So the reason I'm doing this, I just want to say, okay, when did we start running this code? And then what I can do is track how much time has elapsed since we started, and that will give us the total duration of the round that we're currently in. Now, I also want to have misses. Now, misses essentially means that we missed a target. So it popped up on the screen and then it disappeared. As soon as we have a certain number of misses, then we're going to end the game. So that's kind of what we're tracking here. And I think those are the only variables we need right now. Okay, so now we have those. Let's go here. And where we have if target size is less than or equal to 0, what we need to do is increment our misses by 1. So misses plus equals 1. Because as soon as the target is removed, because the size is equal to 0, that means we didn't press on the target and it appeared and disappeared and we didn't see it. So we need to increment misses. Whereas if we collide with the target when we're pressing our mouse on it, then that means it was a successful click. Okay, so now what I'm going to do is I'm going to write a variable called click, and I'm going to make this equal to false. What I'll now do is I'll look inside of my events. I'll see if the user pressed the mouse down. If they did, then I want to set click equal to true. So then we check if the current mouse position has collided with the target. So I'm going to say if event.type is equal to, and this is going to be Pygame dot event dot, actually, no, it's going to be Pygame dot mouse button down. Sorry, that's the event there. Then we're going to say click equals true, and we're going to say clicks plus equals 1 because we've pressed. So we're going to increment the number of clicks that we have in total. Okay, great. So we've now set click equal to true, clicks plus equals 1. Now we need to handle colliding with our targets. Now, the way that I like to do this is just by writing a simple method on each of my targets or on my target class. So I'm going to go here and say define collide, and we're going to take in an X and Y position, which will represent the mouse position that we want to see if we've collided with this circle. All right, so performing collision for our circle is fairly straightforward because we're just looking at the center coordinate of our mouse position versus the center coordinate of our circle position. So what we can do is we can simply take the straight line distance from the 2 points and see if that distance is less than or equal to the radius of our circle. If that's the case, then we've pressed on the circle. I don't really know how to explain it much more than that, but essentially, if you have some kind of distance between your mouse position and the circle, and it's less than or equal to the radius, then you're within the circle. If it's greater than the radius, then you are outside of the circle. There's other ways to perform this collision, but this is probably the easiest. So how do we get this? Well, what we need to do is use the distance to a point formula, and that is going to be the following. It's going to be self.x minus x, and then all of this is going to be raised to the exponent 2. We're then going to add that to the self.y minus the y, and we're going to raise that to the exponent 2, and we're going to take the square root of all of this. We're going to say math.sqrt of all of that. That's going to be the distance between the 2 points. I'm going to double check this because it's been a long time since I've written this formula. And then we are simply going to return if the distance is less than or equal to the size. And this is going to be the self.size. Okay. Now, the only thing you need to kind of follow when you're writing this formula is that whatever order you put the coordinates in, you need to maintain that. So in this case, I'm using the coordinates of my circle first, and then the coordinates of my mouse. Since I'm raising this to the exponent 2, it essentially gives me the absolute value of this first component. Then the same thing will happen here. All I'm trying to say is I can't swap this and do like y minus self.y. If I wanted to do that, I would have to swap the other coordinate as well and say x minus self.x. Either order works. You just have to maintain the same order when you do this. So we'll go in this order, and you'll see this is fine. Okay, so now we have this collide function. Now that we have that, we can start using it. So notice we've kind of tracked if we clicked here. So if we did click, then we want to check if we're colliding with our different targets. So I'm going to say if click, and then we'll say target.collide, and then we need to get our mouse's position. So up here, I'm going to say the mouse underscore position is equal to Pygame mouse.get_pause. And then what I'll do is pass that position. So I'm actually going to pass an asterisk and then the mouse pause. Now, when you use an asterisk inside of function arguments, what this will do is break down the tuple into its individual components. So that might be confusing, but mouse position gives us the XY coordinate of the mouse in Pygame. So since this is a tuple, this is considered one object, right? Like pause is equal to XY. But you can see that inside of our function, right, we're taking X and Y. We're not taking a tuple that contains X and Y. So what we need to do is break this tuple into its individual elements by using the asterisk. So when I do this, it essentially takes the first element, passes that as one positional argument. Takes the second element, passes that as another positional argument. So it's equal or equivalent to me passing mouse position 0 and mouse position 1. It's just a shorthand for doing that, okay? So we're just going to use the asterisk. This is known as the splat operator. Okay, so if we have clicked and we are colliding with this target, then make it disappear. So to make it disappear, we'll simply remove the target and we'll increment the targets pressed by 1. Okay, so target pressed plus equals 1. There you go. That's all we need to do for handling our collision. So let's run this now and let's see if this works. And we get an error. What is the error here? It says some issue. Let me just run this again with the terminal open. For some reason, my terminal keeps cutting off the errors. It says int object has no attribute self. Y.self. Okay, so I can see why we got that error. So let's go back and fix this. I'm sure you guys probably caught that yourself. It's not y.self, it's self.y. Okay, so now let's run this and see what happens when we press the targets and notice that they disappear. Meanwhile, if I click outside the target, it doesn't disappear because, well, we weren't within the bounds. So now we've already kind of got the core logic working here for pressing the targets. What we need to do next is really just display some of our statistics and then end the game, and we'll be finished with this tutorial. All right, so what we're going to do now is we're going to draw kind of a top bar that will contain some of the statistics for our app or for our round or game or whatever you want to call it. So the way we'll do that is we'll write a new function here called define draw top bar. Now to draw this top bar, we're going to take in the window and we need to take in some stats, right? Some information that we want to display. So what we'll take is the elapsed underscore time. We'll take the targets pressed, and we'll take the number of misses that you currently have, because what we'll do is we'll kind of track the number of lives remaining until we need to end the game, right? So that's the next thing we need to do as well. If you've missed more than 3 targets, well, we need to end the game, or however many lives we define. So let's actually define that up here. Let's go ahead and say lives is equal to, and let's set our lives equal to 3. We can then just quickly write some code down here. We can say if the misses is greater than or equal to the lives, then what we will do is we'll just say pass, but really this is where we need to end the game, okay? So if the number of misses we have, the number of targets we have impressed is greater than or equal to the number of lives we have, then we end the game. We also could just subtract from the lives, but I think this is fine as well. Okay, then while we're at it, we'll just call draw top bar and we'll pass in the information we need. So we need the window, we need the elapsed time. Well, to get the elapsed time, we'll create a variable. So we'll say elapsed time is equal to time.time minus start time. So remember, I was telling you if we have access to the start time, then we can get the amount of time that's been elapsed by taking the current time and subtracting that from the start time. That's all it's doing, gives us current time minus the time we started. This will give us the number of seconds that have elapsed. So now we'll pass the elapsed time variable. We then will pass the targets pressed, and then we'll pass the number of misses that we had. Okay, why is that kind of highlighting here? All right, not sure why that's giving us that weird error, but regardless, let's go here. Okay, so now inside of this function, we want to draw this top bar. Now this top bar is really just going to be a rectangle that has some text on it. So let's draw a rectangle, and then we'll draw the rest of the stuff we need. So let's say pygame.draw.rect. Now this is how you draw a rectangle. You use rect, not rectangle. Then we're going to draw this on the window. We need to choose the color we want, so I'll just go with gray. And then we need to pass a rectangle object. Now, a rectangle object is going to be the X and Y of the top left-hand corner where we want to draw the rectangle, and then the width and the height for that corresponding rectangle. So we're going to draw this at 0, 0, because we want it to take up the entire screen. 0, 0, by the way, is going to be the top left-hand corner of our Pygame window. Okay, so we always start at 0, 0 from the top left. Then we need to pass the width and the height. Well, the width of our rectangle is going to be the width of the window. So we'll just pass width. And then the height is going to be some defined height that we're actually going to put in a variable. So we'll go here and we'll say top bar height is equal to, and we'll just go with a height of 50. We can use whatever height we want, but I think 50 is fine. Then I'm just going to pass my top bar height here and draw it there. Okay, so now this will draw a rectangle onto the screen. Next, what we need to do is draw a bunch of different kind of text objects on the screen that represent our different statistics. So this is where it gets actually a little complicated. But whenever we want to draw text in Pygame, we need to create a font object and then render an instance of that font. So what we'll do is go to the top of our program and we'll say our label underscore font is equal to pygame.font.sys font. And then we need to pass a font. So in this case, I'll go with Comic Sans. You can pick any font you want that's supported by Pygame, but I just recommend going with this. And then you choose the font size. In this case, I want to go with 24. Now you can see there's some other kind of things you can do here too. Like you can pass if it is bold, italic, etc. In our case, we'll just go with the standard Comic Sans of size 24. Okay, so now we need to render this font. So the process is create the font object, then you render an instance of the font, then you draw that onto the screen. So the first thing we'll draw is our time. So we're going to say the time underscore label is equal to, and this will be our label font dot render. Now what you do in the render is you pass a string of the text you want to render. You pass 1 for anti-aliasing. Don't worry about that. Just pass 1. And then for the color, you pass the color that you want it to be. In this case, we can draw it in black. Now for the text that we want to draw here, essentially we want to take our time, which is in seconds, and we want to convert it into minutes, seconds, and then milliseconds. So the way I'm going to do that is I'm just going to write a function called format underscore time. Now format time is going to take in the number of seconds that we have, and it's going to return to us a string that contains the number of milliseconds, seconds, and minutes in a nicely formatted kind of thing, okay? So we're going to say milli for milliseconds is equal to math.floor, which will round something down. Inside of here, we're going to take the int of our seconds multiplied by 1,000 modulus 1,000 divided by 100. Now, what this will do is just give us the number of milliseconds that we want to be displaying, okay? I know this seems a little bit weird. I'm not really going to explain it too much. You can try to kind of break it down yourself. It just gives us the number of milliseconds from this seconds, which will contain a bunch of decimal places. Then we're going to have seconds. Now, seconds is going to be equal to the int of the rounded seconds mod 60. And we're going to round this to the first decimal place. Okay, what we're doing is we're taking the number of seconds, we're modding it by 60. That'll give us the number of seconds that we have. And then we will handle the number of minutes here by doing an integer division. So I'm going to say minutes is equal to int. And then this is seconds, integer divided by 60. We need the mod here to make sure we don't get something like 70 seconds or 90 seconds, because that's going to be handled by our minutes. Okay, so now, actually, sorry, that shouldn't be seconds. This should be secs like this, because we need to use the same value. All right, now that we have that, we're going to return a string. I'm going to return an f string, which is new in Python 3.7 and above, or maybe 3.6 and above. Anyways, inside of the f string, you can use these curly braces to embed variables. So I'm going to say minutes colon 02d. Now the 02d means I want to pad this number such that it always has 2 digits. And if it doesn't have 2 digits, start it with a 0. So this will format it such that you get like 01, 02, 03, or 00 if we have no minutes, which is kind of what we want. Then we're going to do seconds. So we're going to do the same thing, 02d. And this is also why I need to convert these into ints, because this only works when you have an int type as opposed to a float type. Okay, so we have our 02d for the formatting, and then we will just put our milliseconds here, like that, which I actually already formatted for us, and we can put that with a dot. We can do a dot or we can do a colon, up to you. I'm going to go with a dot. Okay, so format time will give us a nicely formatted time string. So now inside of our label font, we're going to put an f string. We're going to put time, colon, then we're going to call format time with the elapsed time. So that will give us the string that we want to display inside of here after we have time. Okay, now that we have this time label, we want to display this on the screen. To do that, I'm going to say win.blit. Blit is how you display another surface. In this case, I want to display the time label surface, which you've just created. I'm going to put what I want to display, which is time label. Then I'm going to put the x, y coordinate of the top left-hand corner of the object I want to display. So I'm going to go with 5, 5, which means the top left-hand corner of this time label will be at 5, 5, and we'll draw downwards and to the right from there to draw our text. Okay, so I think that's all we need now. What I'm just going to do is I'm going to take this pygame.display.update out of my draw function, and I'm going to put that inside of here. All right, so I'm going to kind of put that down here. And what's the issue here? It says targets pressed is not defined. Did I not have that defined? Targets pressed, okay. And then let's go here to the click. Targets pressed plus equals 1. Okay, so I just need to fix that variable name. Apologize about that. I have my display now outside of these two functions that we're displaying afterwards. And now if we run the code, we should see we get our time displaying up here nicely. So notice since I drew it at 5, 5, it's 5 pixels down, 5 from the left. That's kind of what we're seeing. Okay, so now that we have the time, we want to display some other information like the number of misses, number of lives, etc. that we have remaining. So let's go here and do the rest. So the next one I want to do is the speed. Now your speed is simply equal to the number of targets you've pressed based on the current time. So like the targets per second. So the way we do that is we take the targets that you've pressed and we divide that by the elapsed time. So I'm going to use my round function. I'm going to take targets pressed and divide that by elapsed time. And I'm going to round this to the first decimal place so we get something like 2.1 or 1.1 or something along those lines. Now that we have the speed, we'll create our speed label, right? Which can be equal to the label font dot render. And then we can go here with an F string and we could say speed colon speed. And then I'll put a T/S standing for targets per second. I then need to put my 1 for the anti-aliasing to be true and then black. And then we can draw this on the screen. So we'll take this, paste this down here, change this to our speed label, and then we're just going to set the X coordinate we want to draw this at. So I want the Y coordinate to be the same, but the X, I need to space this out from my time label. So I'll just set this to be 200 so it goes a bit further to the right. Now let's do the rest of our labels. So let's copy this. So next we'll have the hits label. This is the number of targets that we've currently pressed. So we'll say hits, and this will be targets pressed. Get rid of the T/S. And then we'll blit that one. So copy this and then draw the hits label. Rather than 200, this time we can go with something like 450. And then lastly, we need to display the number of lives we have remaining. So we'll say lives label is equal to, and then I really should just copy this. So let's copy that there. And we'll say lives is equal to the total number of lives minus the number of misses that we currently have. Okay, then we'll draw this one with the lives label. And we'll draw this at 650. Okay, so I think that's going to be good for the top bar. Let's run this now. And you should see that as we press targets, we start updating our different stats. However, you'll notice that some of our targets are appearing at the top bar. I'm going to show you how we fix that in 1 second. And you can see our lives are subtracting kind of as we miss the targets. Okay, so why are they appearing in the top bar? Well, the reason they're appearing in the top bar is because we haven't padded where we want to render the targets based on the position of the top bar. So what we'll need to do now is go to where we have the randomly generated positions. And for our X coordinate, we'll just say our target padding plus the top bar height, just to make sure the minimum Y coordinate is always going to be beneath that top bar. So now that we've done that, if we run this, we should see that none of our targets will be rendered in that top bar anymore. They can be close to it, but they're always going to be bordering it. They'll never be kind of beneath it, meaning we're not going to miss them. Now, obviously, I'm performing quite poorly here because, well, I'm under pressure and I'm on the video. I'm sure you guys will be doing better than me. Okay, almost done here. Last thing we need to do is simply end the game once the user has no more lives. So how do we do that? Well, to end the game, we are simply going to call a function that will display the user's stats. So very similar to drawing the top bar, we're going to draw a bunch of stats onto the screen. So I'm going to write another function called endScreen. Now this is the last function we need. And inside of endScreen, we're going to take win, the elapsed time, the targets underscore pressed, and the number of clicks that you had so that we can calculate what the accuracy is. Now what we'll do in here is we'll essentially kind of pause the execution of our code, and we will render something onto the screen that displays the stats. And then as soon as the user presses a button, we'll just end the game, okay? So what I'm going to do is say win.blit, and then we're going to blit the background color so that we clear whatever was currently on the screen. Because what I want to do is just have some text that appears in the middle of the screen. So what we'll now do is we'll copy kind of all of the text we had from here, and we'll paste this in. But now I only want to display a few things. So I don't need to display the lives anymore. I can display the hits, but I also want to display the accuracy, okay? So accuracy, I don't know if I spelled that correctly. And then I'm going to define the accuracy here. So for the accuracy, this is simply going to be equal to the number of targets we've pressed divided by the number of clicks that we had. So I'm going to say round the targets pressed divided by the clicks multiplied by 100. We'll round that. Actually, do we even need to round this? Yeah, we'll round that to 1 decimal place. Okay, so this is going to be the accuracy that we have. So now we'll just change this text to be accuracy, and then we'll display the accuracy and then %. Now what I'll do is I'll take these different labels and I'll just render them in a slightly different position on the screen so that it is in the center, right? Because here we're displaying them on the top bar. Now we want to display them in the middle of the screen. So to display them in the middle of the screen, I'll actually copy this. Rather than the lives label now, I'll have the accuracy label. And we just need to change these here so that we're rendering in the middle of the screen. Now, the way we render in the middle of the screen when we're using a label is we need to take the middle coordinate of the screen, okay? So it's a bit difficult to explain this visually or without having a visual. So let's actually go into Paint quickly here. Let's imagine we have a screen, okay? If we want to display something in the middle of the screen like this, the natural thing to do would be, okay, well, let me just find kind of this middle X position and then start drawing here. Well, that works if you have something like a circle where you're drawing in the middle of the circle, but in our case, we're drawing from the top left-hand corner, which means if we draw something from the middle coordinate, we end up drawing it to the right and down. So what we actually need to do is draw from the middle, so let's say this is X over 2, minus the width of the object we're drawing minus 2. Or sorry, not minus 2, over 2. So if you take the width of the object over 2, which is this right here, and you now move back by that to here, then you start drawing the object in the middle of the screen. Hopefully that makes a bit of sense what I just explained. But we're going to take the kind of width of the entire screen, divide that by 2, then subtract that by the width of the object that we're drawing over 2. That will then give us the X position where we need to draw the top left-hand corner such that the object will be in the middle. So let's get rid of that, and let's make a function that calculates that for us. So we'll say define get middle. This is going to take in a surface, okay? And what this is going to return is that middle position. So we're going to say width over 2 minus the surface.get underscore width over 2. So now we can use this function on our different labels to determine what X coordinate we should draw them at. So we're going to say for the time label, well, we want to draw this at get middle of the time label. Then for the speed, this is going to be get middle of the speed label. And then for the hits, this is going to be get middle of the hits label. And then for the accuracy, get middle of the accuracy label. Okay, so that should be good, and that should draw everything on the screen. However, what I want to do is have it so it kind of pauses until the user presses something. So what I'm going to do here is I'm going to manually update the screen. So pygame.display.update. I'm then going to run a while loop in here that will wait for the user to press something. Once they press something, it will then close the screen. So I'm going to say run equals true. I'm going to say while run. I'm going to say for event in pygame.event.get. I'm going to say if event.type is equal to pygame dot in all capitals quit, then I am simply going to say quit like that. Otherwise, I'm going to say if event.type is equal to pygame, and this will be dot, and we'll go with key down. So this just means if we press any key down, then I'm going to say run equals false, and I will break out of this loop. Now what this quit function will do is just completely quit the Python program for us, and then what this will do is kind of just exit the loop, which will then cause us to get out. Now what I could actually do is just put quit here as well, or I could make this even a little bit more elegant, and I could copy this all and say, or it equals this, and now we just have that in one line. So we really just have this one while loop. This is just kind of running forever and just waiting for us to press any key or to click quit. As soon as we do that, we just close the window. Okay, so now all we need to do is call this end screen function as soon as we kind of lose the game. So we'll go here, and rather than pass, we'll call end screen, and we'll pass this the information we need. So we need the window. What else do we need? The elapsed time, the targets pressed, So targets pressed and the number of clicks. Okay, so now we should be fully finished our program. Let's run this and make sure it works. And let's just see what happens now if we kind of click a few of the things here. And then we kind of let some of our lives run out. Okay, 2, 1, and we got an error. Let's see what that error is. Was it an error or did it just quit immediately? Let's see here. Give this a second. Okay, argument 1 must be Pygame surface, not tuple. Win.blit. Okay. Sorry about that, guys. Let's go fix this now. Go in end screen, and rather than win.blit, this is going to be win.fill. So we need to fill with the background color, not blit with it. That's my bad. Let's give this another shot here. Click a few targets. Okay. And now let's lose. So 2 lives, 1 live, and it shows our information. However, it's showing it all on one single line. That's because we didn't change the Y positions. So let's make these like 100, 200, 300, and 400. And while we're at it, let's change the color here to be white, because black is a little bit of an eyesore there on the blue background. So let's change these all to be white and white. And let's run this. And now let's just run a few targets or click a few targets and kind of let this lose and see if it displays correctly for us. All right, so there you go. We got our time, our speed, our hits, and our accuracy, and we have finished this project. With that said, I'm going to wrap up the video here. I hope you guys found this helpful and that this was a cool project that you're able to kind of work on, you could show to people, and that could kind of improve your Python knowledge. What I will be doing is including all of the code in the link in the description in case you want to download any of it or in case you get lost, so feel free to check that out. Anyways, if you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another one.